structure is called a pulsar wind nebula. No clear explanation is yet known for the unusual shape of this supernova remnant. One possibility is that we are seeing the effects of a shock wave bouncing backwards off of the shell of material swept up by the blast wave. The X-ray observations allow scientists to estimate the energy released during the supernova explosion and the age of the remnant, as well as the amount of material being swept up as the blast wave from the explosion expands.
After completing its primary mission to map the infrared sky, NASA's Wide Field Infrared Survey Explorer, or WISE, has reached the expected end of its onboard supply of frozen coolant. Although WISE has warmed up, NASA has decided the mission will still continue. WISE will now focus on our nearest neighbors, the asteroids and comets traveling together with our solar system's planets around the Sun. The NEO-WISE post-cryogenic mission is designed to complete the survey of the solar system and finish the second survey of the rest of the sky at its new warmer temperature of about minus 334 degrees Fahrenheit using its two shortest wavelength detectors. The survey extension will last 1 to 4 months depending on early results. WISE launched December 14, 2009 from Vandenberg Air Force Station in California aboard a Delta II launch vehicle. Its 16-inch infrared telescope scans the skies from an Earth-circling orbit crossing the poles. It has already snapped more than 1.8 million pictures at 4 infrared wavelengths. Currently, the survey has covered the sky about 1.5 times, producing a vast catalog containing hundreds of millions of objects from near-Earth asteroids to cool stars called brown dwarfs to distant luminous galaxies. To date, WISE has discovered 19 comets and more than 33,000 asteroids, including 120 near-Earth objects, which are those bodies with orbits that pass relatively close to the Earth's path around the Sun. More discoveries regarding objects outside our solar system, such as the brown dwarfs and luminous galaxies, are expected.
The mission was designed for a 9-month all-sky survey, and we have met all our mission objectives, and the whole sky has been surveyed in the infrared. The mission actually has 4 detectors, 2 in a slightly shorter wavelength and 2 longer wavelengths. When the instrument heats up, the 2 longer wavelength detector can no more be used because of the background. But the 2 shorter wavelengths can still do a limited amount of science. And the science that we hope to achieve is to look at asteroids and near-Earth objects. And so we plan to run the mission for another month to see how much of the near-Earth objects we can actually see. And if it turns out that we can see a significant number of them, then we may extend the mission a little longer. The all-sky survey is going to produce an atlas of all the objects in the sky. Plus, we are going to also take out some, not only all the images, but actually identify some of the objects. And this will then give astronomers a chance to study all that there is in the infrared sky. All the scientific objectives have been met, and we are on track to get the data all archived and to release the first set of images to the scientific community. About 55% of the sky should be released in mid-April, and this will then be available to the entire scientific community to analyze and get new science. And we hope to release the rest of the data the following year according to schedule.